All right, atomic structure 10, chemical properties of elements, part 2. Well, in part 1, last video, we talked about physical and chemical properties. So I just want to add more to the chemical properties, just reviewing them. And remember, this is very important. In chemical properties, the substance, the element, will change. It will turn into something else. Like we talked about wood. If you burn wood, it will turn to ash, and ash is not wood. In physical properties, and like an ice cube, for example, the element does not change. So an ice cube, if it melts, it's still water, right? An ice cube is water, and if it melts, it's still water. So let's look at some chemical changes. Let me get our pen going here. And we talked about these in the last video, right? We just talked about fire, right? You burn wood, it turns to ash, and iron will rust. Photosynthesis, this is all chemical changes. All right, so let me get my pen. I said that before, I'll say it again. And let's look at this chart. So again, in a chemical change, you're going to have a new substance produced. So let's look at the first one. And my pen disappeared. Let's use purple. Why not? And we look at the first one. It says production of heat. So that's a clue on a chemical change. So for example, if you mixed, we'll put it up here, if you mix pure sodium, sodium I'm talking about, not sodium chloride, which is table salt, but pure sodium, that soft silver alkali, and you mixed it with water, you're going to get a violent reaction, and you will produce heat. Heat will be produced. You'll feel it. You put that, let's say here's a beaker. We have our beaker in the lab, and it's filled with a little water in here like that. And then we throw we'll just use that color for our sodium, even though it's not that color. You throw that in there, and you'll notice that the sodium will move around the water because it's reacting, and it's going to create hydrogen gas. It's going to create hydrogen gas. And if you put your hand on that beaker, you will feel the heat. So right there, next one, it's going to produce gas that's not present in the reactants. Remember, the reactants are the initial elements that will make a new thing, a product. Okay. So what about a change in color? Let's look at that one. And let's clear this out. So we talked about heat with sodium. By the way, if you take any alkali, take ones going even down, put potassium in water, it will react even more. You'll feel more heat. Even if you put like magnesium and so forth, it's going to create heat. And it'll create light because it can create fire. Fire could shoot out of here if you put enough of it in. Okay, so now let's talk about a permanent change in color. Let's clear this out, and we'll go to red. Permanent change in color. Now that happens, a good example is with copper. Copper, you know the color of copper, kind of looks like this, something like that. Let's say that's copper. Well, eventually, over time, copper will turn green. It'll turn green. And this has happened. A good example is with the statue, our famous Statue of Liberty, Miss Liberty in the New York Harbor. Right? Some people say it's in New Jersey Harbor. It's actually closer to New Jersey, but that's another story. So the Statue of Liberty that the French gave us in pieces, it was originally a copper color, and eventually over time it just turned green. So that's an example right there, permanent change of color. All right. And by the way, the Statue of Liberty, it took about 30 years for it to turn green. Some people may say 25 years. All right, so let's look at this. The next one, we'll clear that out. We'll use that color. Why not? Production of a precipitate. A precipitate. So let me show you a picture of that. All it is when you have a solution and then you get a solid on the bottom of a tube. For example, let's say you had this, right, and you had two liquids in here, and eventually what you would have is it's almost like sediment. So let's use a different color. Use purple. So you have this thing, this solid forming. That is the precipitate, the solid. Let's get a better picture on that, by the way. Here's a better picture. So let's use red. So here we have a solution. Let's say you had a solution of sodium chloride, right? We'll write sodium chloride over here, which is this table salt, sodium chloride. And then you mixed it with silver nitrate, both liquids. So if you mix this, in the end, you will have silver chloride. Silver chloride will be the solid. The precipitate will be the solid. That's what that means. And the supernatant is just the liquid that's hovering above the precipitate. So I'll leave that there for a couple of seconds if you need to write things down. So again, two liquids, and then at the end you have this solid. Think of it as debris forming. All right, let's go back. So we already talked about the production of heat. When we mixed any kind of alkali with water, we'll get heat. We'll also get fire. Some fire depends on how much of the alkali you put in. If we put in sodium or potassium, it's going to create a lot of heat and could create light. Now, production of gas, I mean, we talked about an example, but also just, let me get my color, come a little red here. So even when you, like we're in, even in middle school and high school, everyone did this baking soda. You did the baking soda and the vinegar experiment. The vinegar. And of course, you got a gas that formed, right? You had that CO2 forming. So there was the gas, production of gas. And we already talked about a change in color with the Statue of Liberty. We talked about what the precipitate is. And this one's obvious, a change in odor and taste because cooking is a chemical reaction, right? So eating a raw egg and a cooked egg will taste a lot different. Now look at this banana. And you've probably seen this a lot. You buy bananas, and within a week, you get this going on. Sometimes you bring them to lunch, and it happens very quickly. So yes, cooking is a change in color and taste. All right, that is chemical changes.